Given an n by 3 matrix costs, row I is house I, and the 3 entries are dollars to paint that house red, then blue, then green. Paint every house so no two neighbors share the same color. Return the minimum possible total cost. Example, 3 houses. Paint house 0 blue for 2. House 1 cannot repeat blue, so paint it green for 5. House 2 cannot repeat green, so paint it blue for 3. 2 plus 5 plus 3 equals 10, the minimum total while alternating colors along the row. Greedy can trap you. If house 1 takes the cheapest color now, the next house may lose its best option. So we cannot optimize one house in isolation, we need accumulated best costs that remember the previous ending color. At each house, keep 3 buckets, best total ending in red, ending in blue, and ending in green. That compact state is enough, we do not need the full color history. To fill one current bucket, we only interview the 2 compatible previous buckets. For example, current blue cannot come from previous blue, so compare previous red path versus previous green path and keep the cheaper sum. Roll these 3 totals house by house. At the final house, take the minimum of the 3 ending buckets. That turns an exponential search over color combinations into a linear pass with constant extra state. Define dp at house I color C as costs, C, plus the cheaper of the 2 non-C totals from house I-1. Row 0 just copies the costs row, since there is nothing before house 0. Take house 1 ending in blue. Add 16 to the cheaper of red 17 and green 17 from house 0. Both are 17, so dp at house 1 blue is 33. Continue filling row 1, then jump to house 2 ending in blue. House 1's red total is 18 and green total is 7, so we pick 7. Add 3, dp at house 2 blue is 10. Fill the rest by the same rule. The answer is the minimum of the last row of dp, min of 21, 10, 37, which is 10. We built the full dp table for clarity, but each new row only reads the previous row's 3 values. So we can keep just rolling variables prev_r, prev_b, and prev_g. Update a new triplet from the old triplet, then overwrite previous values. That is why extra space is constant. Let n be the number of houses. Time is O of n, because each house computes 3 states using constant work per state. Space is O of 1 extra if we keep only the previous row's 3 totals. If you keep the full table for teaching visuals, that display storage is O of n times 3. Define the function that returns the minimum paint cost. Initialize previous row totals from the first house costs. Loop houses from index 1 to the last index. Compute current red using the cheaper previous blue or green path. Compute current blue using the cheaper previous red or green path. Compute current green using the cheaper previous red or blue path. Shift previous totals to this current row. After all houses, the answer is the minimum of the 3 totals. Return that minimum value.